about water and urban places. This is Ideanthro.
Hey everyone, and welcome back to Ideanthro. If you've been watching the past couple of episodes, you will have seen that we are digging into a fascinating site with several bioretention systems, a natural channel or pseudo-natural channel, some erosion, some mysterious silt. We started this 2 episodes back, and we're continuing it with this chat because we've had some interesting questions and conversations arise out of the site. True to the name of the first episode when we started talking about this, this is a fascinating site. Now, for today's episode, we have a guest with us who I will get to in just a second. But to set the context here, we have a site, 5 bioretention systems, pseudo-natural channel. There's sediment in the bioretention system's kind of mysterious. There's potentially an eroding creek. And we're going to dig into this. Our guest today, who in a second I'll ask him to give you a little bit of a background to who he is. But our guest today is Herman Paulens, who is joining us from Germany. And Herman, you asked me, I suppose we started having a conversation in the comments on YouTube and LinkedIn about this. So here we are now to, I suppose, have a chat in person. Before we get into this, do you just want to give people a brief snapshot of kind of who you are so people know who's chatting, and then we can talk about the site?
Sure. So I'm originally from Germany and lived in Australia for 6 years, and I worked as an integrated water engineer in Melbourne. And I met you at a Clearwater event, and we got chatting, and I've been following your videos since. And now I'm back in Europe and still interested in your stuff.
Yeah, awesome. Okay, cool. Good context. Why don't we start this conversation? There's a few different ways we could get into this, but why don't we start this with a bit of new information that I can add to this story since I last put out a video here. So the hypothesis with this site was we've got these sites that are where the bioretention systems, they're online to a pseudo-natural channel. It's a development that's for the bottom bioretention basin, it's about a 25 hectare catchment thereabouts. And we've got this somewhat mysterious source of sediment. So the whole video is about trying to unpick where the sediments come from. And the hypothesis that I left the first video with was, I think it's coming from the waterway eroding. There might also be some original sediment from, say, house spinning sites when the catchment was built, but I think there is an ongoing source of sediment coming from the eroding waterway. And we finished that video with me kind of kneeling down in a creek, pushing into it with my thumb, and there's a little bit of a base flow kind of running through the creek. And I push in, it's soft, and you kind of see it dissolve as I push on it with my thumb. Well, since I recorded that, because I recorded the video sometime before I actually released it, there's been a little bit of an investigation with some geotech done here. And the report came back essentially saying not a lot of risk of creek erosion. And it described, depending on where we were in the waterway, it described the sediments as either, and I'm going to try and pull this up here so I can read this properly, as either very stiff sandy clays of anticipated alluvial or colluvial origin. So that was one part of it. So very stiff sandy clays. Or in another part of the waterway, described it as, let me get this right, very low strength sandstone. But the conclusion that came out of it was that the waterway wasn't particularly prone to erosion. So the first thing that's kind of puzzling me now with this is that how do I reconcile the fact that on the one hand, I can stick my thumb into this and it appears to dissolve under my very fingers. But on the other hand, I've got a geotech report saying, yeah, you know what? It's not that erosive. So that's a bit of information I'd like to put out there. What springs to your mind when I say that? I realize you haven't had a chance to see the site or anything, but let's just start chatting this through.
Yeah, so I think it might be interesting to find out exactly how they came to that conclusion that it's not erosive, and if the waterway could be erosive under a high intensity rainfall scenario where you get big flows coming down the channel and then actually getting channeled away rather quickly and then causing some erosion. And if the testing is maybe done in a different way, that it doesn't by itself dissolve into the water, but under high strain scenarios and high shear stress scenarios, it would actually erode and then end up in the biofiltration system.
Yeah. I mean, that's a good point, because I realized that when it comes to kind of geotech and creek erosion, like I'm on the edge of my my knowledge by certainly, listed assets are my thing. Creek erosion, like no bits, but I'm on the edge of my knowledge for sure.
Yeah.
There. So perhaps
I mean,
maybe that's
natural system erosion is it's a natural process. Like I'm investigating lots of scenarios in Germany where people are renaturing waterways in a big scale. So there's this project that I have an interview with on Friday, where they're actually renaturing 350 kilometers of an former open sewer back into a creek. And the way they do it is they basically just remove the concrete base that they have, and they remove the dikes around it, and they just let the river naturally erode it into shape that it wants to. So they use the natural erosion to create a constructed waterway. So erosion it's not always a bad thing, and it's a natural process. So the question is.
Sorry, you go. You keep going.
Yeah. So the question for me is always, if we have an urban flow scenario with high peaks, is that creating a natural waterway?
Yeah, it's a good question. I don't think it is. And so there's also some question mark about the history of this site and what exactly was here in the way of a waterway to begin with. So, was there something you'd recognise as a waterway? Was it an ephemeral waterway? Was it just an overland flow path? Or has the landscape been so completely terraformed that it actually wasn't even a low point in the landscape before the development happened? None of those things are entirely clear to me. But I think you do raise one very good point here, which is about the fact that erosion's a natural process, and waterways move in order to use up energy. But when we come to an urban system, we put a whole bunch of constraints on where a waterway can move to, whether that's the points that we tell it that it's going to cross underneath a road, or whether that's the property boundaries beside it where we're not happy for it to migrate laterally, or whether in the case of this site, it's the point at which it enters and leaves each bioretention system, because you barely get a run of more than, I doubt more than 50 meters at a time down this little channel, at least between the bioretention systems. There's more upstream, there's more downstream of the last one, but between the systems, you probably don't get a run of more than 50, maybe 100 meters at a time of actual waterway between the basins. And so if the outflow of one is fixed and the inflow of the next is fixed, there's not a lot of options for that waterway to get rid of energy besides cutting down.
Yeah. So when you were in the last video, though, the point where you stuck your thumb into the base of the creek, that was at the lower at the outflow of the creek. So there was exposed basically, the sandstone was exposed at the outflow.
Yes,
it wasn't only at the inflow that it was eroding. So even after the retention function of the bioretention systems, you could still see basically the bare, rock underneath.
Yeah, and it's worse lower down. There's certainly, you can see the bare, let's call it bedrock. You can see it above the first basin, and you can see it between 1 and 2. You don't really see it between 2 and 3 because they're very, very close to each other. You see it a bit between 3 and even 2 and 3. Even 3 and 4 are quite close. You see it a bit between 4 and 5, and then you see it downstream of 5 as well. And it's worst between 4 and 5 and downstream of 5 for sure.
Which is interesting.
Yeah, although there are additional catchments coming in. Like by the time, the catchment of the first basin is, let's say, roughly 15 hectares. And by the time you get to beneath the fifth one, you've got a catchment of, for most of its history, well, for the most part, about 25 hectares, although there is another, this is where the hydraulics of urban areas just go crazy. There is another external catchment that probably overtops into the system. This is another development that's now happening beside it, that has almost like an emergency overland flow channel into this system. Although there's not any, we go and look around there, it doesn't look like there's any evidence that it's ever been engaged, but theoretically there is a whole nother big external catchment that drops into maybe Basin 4, I think it would be.
So there could be something additional that, we hadn't considered previously or something.
Yeah, it's possible. As I say, I don't think that's ever been engaged, but I don't know for sure. It could have been, and just stuff's grown back up and hidden the evidence of it.
Yeah.
You mentioned the site that you're going to be visiting or kind of looking into in Germany.
Yeah.
What's their approach to, constraints to how much? So you're saying that they're letting the channels erode to find their natural place in the landscape.
Yeah.
What's their approach then to constraints? Because there's got to be some pinch points where they're like, look, at this point we're not happy for it to move laterally. It's a very, very the most populated area in Germany where this channel is located, and so they are artificially creating areas that previously were used for agriculture or something, and given it a more area to move. So they introduce basically natural flood plains in certain spots. So the river's not free to move at all spots, I don't think. But they kind of now starting to expand and make wider the original corridor for the creek. And so they're still giving it an engineered corridor in some spots, and in other spots where they have the land, they actually carve out a big floodplain for it and then let it move across the floodplain as it wants to. Yeah, okay, gotcha. And sorry, I realise I'm now taking this down the tangent of the site that you're visiting, but I'm really curious. What do you know of is the sediment that's eroding out of the waterway considered a pollutant? Like is that just going to the sea and so be it, or?
No, so this site is very, very special. I don't know if we want to talk about it, but it used to be an open sewer, the whole thing, and they had one treatment plant at the end of it, and they treated the whole river. So the whole river went into a treatment plant and then went out. Yeah. And now they're trying to they put the sewage underground because they can now. Previously, it was a mining area, and so because when you mine the coal, the ground gives way and changes, and so they couldn't put underground pipes in because they would be destroyed by the movement of the ground. And now all the coal mining stopped, and now they replace it with they can actually use pipes, and so they use pipes and they leave the actual river back to its natural state. So it's a very complicated, huge undertaking.
Yeah, and certainly, or maybe not unique, but it's a very particular case for sure.
Yeah.
Okay, sorry. I'm keen to hear more about that.
So it's a very large area. So it's 400 kilometers long, and so I reckon the soils are very different, and they still have a treatment plant at the end.
Yeah. Okay. Right. Gotcha. Okay. So bringing this back to the particular site at hand.
Yeah. So what did you think about sort of ways of solving a few of the problems? So as I took it away, the main problem was really that all the media was clogged with fine particulates and basically also overgrown. And, there's certain different ways of solving this. You could look at the source of the sediment, or you could look at the actual system and if it's the right fit for the catchment.
Yeah, so I've got a few different thoughts on this. And it just, to no small degree, it hinges on the geotech and what the creek is actually doing. So, I mean, we can hypothesize a few different things. Actually, and remind me, I'll come back to this. Remind me to say something interesting that I may not have mentioned in the first video about the sediment in the first basin. But if the waterway is still actively eroding, let's just talk about the very first basin. And partly that's because that's the one that's most likely to be worked on first because it's upstream of this. But it just helps to simplify this discussion for me, and it's the one I'm most familiar with at the moment. If the waterway is still actively eroding upstream of the first basin, then I don't see a lot of point in doing costly works to rehabilitate the first basin if we think it's just going to clog up again.
Yeah. So you need to find out if it's still actively eroding.
Yeah, and that's why that question's so fascinating for me. My assumption was it's actively eroding, but then got this geotech that suggests that it might not be. So we got a decision point there. Let's for a minute just assume it's not actively eroding. Then I could see it goes down either one of two paths. Either it's come in, do a big reset job and effectively rebuild it, revegetate it. Or on the flip side, the one thing that we do know about it is that it does drain to some degree. To what degree? Probably not that quickly, given the hydraulic conductivity tests that I did were running pretty slowly. But it does drain to some degree. So if you're limited with funds, there is certainly an option. There are certainly options to either A, leave it completely as is and just let the weeds go into it and let it be a weedy basin, but a weedy basin is probably not that bad. Still lots of vegetation. There's nothing to say for sure that a really weedy basin wouldn't do really good treatment. Or you could potentially come in and do revegetation of it. So don't remove any of the clogging and just revegetate it with species that you think are most likely to help mitigate that clogging. So things like melaleuca trees are particularly good at mitigating clogging. Carex suppressor with its incredible root system, good for that as well. So you could certainly revegetate it. And I have a site that I worked on about 7 years ago, which is a precedence for using vegetation to restore the hydraulic conductivity of a very, very clogged up system. So you could do that. So you've got a few options there. I reckon to some degree, to a big degree, the one that I pick would be based on how much money do I have, because you're talking about, the difference between spending several $100,000 versus spending, maybe $10,000-$20,000, depending on how significant the re-veg job was. So we've got an order of magnitude difference in the funding there. For me, a big part of which way I'd go in that instance would depend on whether the erosion was active downstream of the site. Because if there's active erosion downstream of the site, then I want this bioretention system working to its absolute best capacity to try and mitigate and slow down as much of the flow here as I can to take the pressure off downstream. And if it's clogged up, it's more likely in big events that it's topping more regularly, et cetera, et cetera, et cetera.
Yeah.
So that's part of the decision tree. So that's kind of the half of if we don't think the waterway's actively eroding upstream of it. But if it is actively eroding upstream, then I think we're split between a few different options. I wouldn't do a complete rebuild of the system unless I felt that I could stabilize the upstream catchment. Again, that's why that geotech's important. So if I didn't feel I could stabilize that, then you're looking at either leave it as weeds or do a re-veg job to get rid of the weeds and again get melaleucas and that sort of thing in there to combat the current and future clogging as best as possible. But I think probably the most interesting one, and I wonder if this is where you were heading with this based on some of our other chats, is let's say that it is actively eroding and we want to do something about the active erosion. How do we do something about it? That's probably the most, it's challenging, but it's also an interesting spot to talk, because suddenly we're talking about retrofits into the existing urban fabric very much at source.
Yeah, yeah. I have actually a few thoughts on this based on just listening to you right now, where I was thinking, is there any way other than a geotech report or, getting second opinion or something on finding out if it's still actively eroding? Could you run an experiment by building, a little check dam wrapped in geofabric in the channel and, wait half a year and see if there's any sediment buildup in front of that or something like that to kind of see if there's still, sediment going through that channel.
I like where this is going, because that's a startlingly simple but really potentially quite interesting suggestion. Would that?
I don't know, because you said it's not very accessible. I'm not sure how expensive it would be, but I'd think just a pile of rocks with geofab wouldn't set you back more than a few grand, I guess.
No, not at all. Would you expect it to? So if the hypothesis here, like based on the lower section of the waterway where I stuck the thumb into it and it appears to just dissolve,
yeah,
feels like we're looking at very clayey material at that point. And it's the fines that bother me most about into bioretention.
Yeah, well, that's why I suggested the geofabric. I don't think, if you do just one little check dam, it probably wouldn't do much to retain fines.
Yeah.
But if you have, some sort of geofabric, or you make it a bit more of an organic barrier or something, you could have like a log jam thing where you put a few trees in it and actually pond the water up a little bit to slow it down and see if you get sedimentation then. And, if you do that as an experiment and it turns out that it does erode, then it could also be a part of the ultimate solution where you say, okay, well, we do have active erosion. We need to slow down the water in the channel or in the catchment so it doesn't erode as much. And then, oh, look, we already have a log jam here, or we already have a check dam there.
The other thing that you might be able to do is, as you were talking, I have a funny feeling that I've heard before of either work being done to test, or this technology might have been completed. Well, but what about, so if you're building a check dam, you're suddenly going to have a bit of a pool of water in the channel. What about some sort of, and this is getting more complicated and more complex, but anyway, what about some form of monitoring there to check for turbidity? Whether that's, and so what I initially thought of was, I swear a couple of years ago that I heard of a project working on technologies to use essentially video, or was it laser tech? I don't know. I can't remember. Essentially, technology where you didn't have to stick something in the water. So let's imagine a camera or a laser or something beside the water, pointing at the water to test the turbidity of it.
Yeah.
So the benefit there could be that, you could build the check dam and it's going to capture coarse material. So you get an indication of if there's any coarse stuff migrating down. But if you had hypothetical sensing equipment sitting there, you could use the pool of water to check for if there was fines moving down as well.
Yeah. No, I think that would work. You could also pay a poor student. I did work like that when I was a student, to actually, drive out in a case of a storm and then take samples and measure turbidity. That works, but you have to be there at the right time, because it's, after 5 minutes or something, it's it clears up very quickly. The first flush is really the main source of the turbidity.
Well, if it's off the catchment, maybe the first flush is, but if it's erosion from the waterway itself, it might not be. It could be consistent.
Well, yeah, it depends on where the peak obviously is. But a peak of 20, or what do you say, 15 hectare catchment might be after 15, 20 minutes or something. So
yeah, you're certainly going to want to respond quickly. Nonetheless. It's interesting. That's given me some stuff to think about, though. You could conceivably even set up 2 check dams, one upstream of the other, and it's probably not sensitive enough to, anyway, hypothetically, ignoring the fact that you just might be too much error. in the measurements, but you could set up two of them and look for any differences between one and the other to see for any increases in turbidity due to channel erosion. The only problem that I see with this is that my hypothesis is that the channel erosion is very slow over time.
Mm-hmm.
Either it's kind of melting away slowly over time, or the flip side to it could be that the erosion could be only in very extreme events. So if you didn't measure an extreme event, you might not pick up any evidence of it.
Yeah.
But nonetheless, there's an idea there to pursue for sure.
So
you go.
Yeah. The other idea was what you sort of alluded to do work with the actual systems that are there, and if there would be a sort of a retrofit scenario, and this is the original comments we had on YouTube, the chats about whether you could convert one of the systems into some sort of wetlandy sediment type treatment device to sort of prevent clogging of all the other systems downstream. And, at the moment, probably the first basin is sort of the sediment capture for the other basins a little bit.
Well, there is an element of this where it's like, in the state that it was in before, so in order to do a bunch of the investigations, we got the basins cleared of weeds just so we could get in and see the things. There's an argument to be made that the first basin was effectively an ephemeral wetland before we cleared the weeds out of it. So I find it difficult to see why I'd be wanting to retrofit the basin into into what we traditionally in Worcester think of as a wetland, where you've got, shallow standing open water and the like. But, some sort of simple vegetation works to turn it to, and a change in mindset to stop thinking about it as a bioretention system that's really permeable and start thinking about it as an ephemeral wetland that does drain eventually, but not super quickly. I think there's a lot of merit in that as a pragmatic, cost-effective solution that doesn't involve rebuilding.
And any sort of settling system that you think about, you probably need to really think about the settling velocity of these particular erosive particles that you get, because there might not be anything like the design sand that you usually want to settle out. It might, possibly if you say, we need a sediment forebay or something, and you design them for the very fine sands that you want to settle out, that might not be actually what you can settle out with the.
Well, and this is, so I mentioned a second ago something fascinating about Basin 1 to come back to. This is where it gets really interesting. So Basin 1 is quite a big basin. It's somewhere in the order of 1,000 square meters, plus or minus a bit. And it's shaped a little bit like a figure of 8, in that there's a bit of a pinch point in the middle. So a figure of 8 where water comes in at the top, there's kind of a rounded open area. There's a bit of a pinch point. Actually, an hourglass is probably a better description of this. Rounded area, pinch point in the middle, rounded spot down the bottom. And there's currently a fallen tree smack bang across the center of it. So it's like really distinctly separated in two, although water gets past, no worries. But on the top half of the basin, there's heaps and heaps and heaps of accumulated sand and no sign of fine sediment deposition in the top half of the basin at all, even when you dig through the profile. So I've dug through the accumulated sand through the filter media and got into the drainage layers below, and we're talking in the order of 600 mils of accumulated sand. Like, I was digging through by hand, and by the time I got through the filter media, I had my head down the hole to be able to dig into it. So at the top end of the basin, we've got this huge amount of accumulated sand, which I have no idea where that came from. And
the construction material, or
possibly, but no sign of any fine sediment accumulation up there, except maybe a little bit on the surface of it in amongst the plants. And then
that makes sense, because they fall out first, and the finer particles would go all the way to the end, and then when it gets more calm water, then
well, and this is it. Then you go down the bottom end of the system, and there's no sign of any sands, but you've got all this fine material, like clayey material. It's not super fine, but it's definitely at the silty clay area end of the spectrum. Very different color, like clearly very different origin. Deposited down the bottom end of the system, and I've just never seen such a clear delineation. Like I've always, whenever I've seen fines accumulate on the surface of the system, it's typically consistently across the whole base. So that's also been fascinating me as to exactly why. And I mean, maybe it's as simple as what you say, which is the fines are getting further in. But just interesting that I've got this. You could feel like you were in two completely different systems, depending on if you're on the top of the hourglass or the bottom of the hourglass.
Yeah. Yeah, the question is really also, is it actually the sandstone that is eroding, or, is all the soily type clay fine particles that you see in the basin, is that actually the topsoil of the channel that got eroded away into the basins?
Yeah, well, that's very possible, because it's just such a mystery where, like, the history of this and where it's all come from. Because if we talk about the colors, then the color of the channel. So the other thing that's going on in Basin 1, and I'm kind of forgetting what I did and didn't mention in the original video. So if anyone's like, wait, you didn't say that, Jack, then, it's a complex story, and I may have simplified it when I originally talked about this. But if you're in Basin 1 and you're in the bottom of the hourglass and you dig through the profile, you go through the accumulated silts and clays on top, which are very dark in color.
Yeah.
And then you get to the filter media, which is more of like a browny, yellowy, let's call it a sandy-ish color.
Yeah.
But that filter media is also very, very tough. It's not sand. It's also contaminated throughout its profile. So the clogging in this system isn't just surface clogging, because I tested the hydraulic conductivity both at the surface and in the filter media itself, and they're both really clogged up. And the color of the filter media, which I believe is contaminated, is much more similar to the color of the sandstones in the channel. So one hypothesis could be that the clogging within the filter media is by very fine material being eroded out of these soft, apparently sandstones. But if it was sandstone, you'd think it would be more sandy. But anyway, but potentially that the clogging in the filter media itself might be coming out of the base of the channel being eroded, but maybe the dark material sitting on top is the original topsoil that was sitting above it until it eroded. And then that just leaves the mystery of where does the sand in the front end of the system come from. But maybe the sand in the front, maybe the sandstones in the waterway still do have a lot of fines in them, actually.
Yeah, exactly. It might be composed of the sand and then the clay that binds it together, and you separate them in the basin.
And I've got a good reason to think that might be the case. Okay, this is going to bring in another part of my my life. So, in a
forensic engineering.
Yeah, I love this. This is why this chat's amazing. So, in a previous life, I competed in a sport called bike trials. We ride a bike over obstacles like rocks and logs and concrete pipes. And if you want to see me do that, you can find an episode about coarse sediment forebays on Ideanthro, where I imply that the only good thing about a coarse sediment forebay is as an obstacle to ride on. But, I don't know, 10 years ago or something, there was a big motorway upgrade in this general area in Brisbane. So probably in the same broad general geological area, probably within the same sorts of underlying rock. And one of my friends who rode and had a property at the time managed to get a bunch of the rock that they extracted during that motorway upgrade delivered to his place for us to ride on. So I've actually ridden on a bunch of this rock. And one of the things was when it was really, really fresh, it kind of flaked away, and it was sandy, but it was also kind of dissolved away and was quite soft. So what I observed at that point of time suggests to me, kind of in line with what you just said, which is, yeah, it's a sandstone, but there's also other fine stuff in there to bind it together. So maybe basin 1, maybe the sand at the front end of the system is the sand from the sandstone. The clogging in the media itself is the fines out of the sandstone, and the dark silts and clays on top of the topsoil that was once on the channel, but just got as far as the first basin and dropped out.
Yeah, or there could be organic material that's just the detritus from all the plants that have been growing inside the retention basin too,
There's definitely, that's definitely part of what that dark layer is. Definitely organic matter in it.
Good hypothesizing here.
Yeah, I mean, if anyone watching this has got suggestions as to how to actually dig into this and sort out this mystery, I'd be keen to hear it. But yeah, it's fascinating spitballing. Are there any other angles that you want to explore this from?
Well, we haven't really talked about anything inside the catchment. I just assumed that there's probably not any opportunity to do anything inside the actual catchment.
Well, I think the question there is, could you do it cost effectively? There's always there's space. If you wanted to build 1 million streetscape bioretention systems, you could do it. It's because it's a subdivision that's in the order of 10 to 15, not quite 15 years old, but a bit more than 10 years old. There's wide verges and the like. You could build streetscape bioretention. You could install rainwater tanks. In fact, many of the houses might already have rainwater tanks because of the era that they're from, and there were probably mandatory water savings targets in place during the time some of the houses were constructed.
Do the roofs drain into a pipe, or do they drain onto the road?
To pipe, and then the pipe goes to the curb and channel on the road. Yeah.
Oh, okay.
So you could go, if there's not already rainwater tanks, you could have rainwater tanks on lot and intercept at source. Or you could go like Melbourne Water style downpipe disconnections and try and, they're not the biggest yards around, but they're not tiny. This was before housing blocks really shrunk in Southeast Queensland. So there's space in the catchment. It's just a matter of the money that would be required, as with any other catchment. But which really...
So would there be any additional benefit to sort of, even if there's no erosion of the channel, would there be any benefit in sort of slowing the water down somehow in the channel?
Yeah, well, I mean, this raises a good point. So let's have a think about this. So we're saying that the catchment, roughly speaking, leading into the first basin is about 15 hectares. And the basin itself is about 1,000 square metres, which means it's a bit undersized by Southeast Queensland standards, but not...
I wouldn't know what the sizes are, but yeah.
Yeah, well, so roughly speaking, you'd expect a basin to be about 1 to, at the upper end, 1.5% of the total catchment area. So obviously at 1,000, maybe a little bit more square metres on a 1,500, we're at like 0.6, 0.7. So it's a bit under, but it's not crazy small. So, and there's not that much channel upstream of Basin 1. So there's an argument to be made, which is the thing to do here is to introduce whatever physical means to stabilize that relatively short length of channel upstream of Basin 1.
Yeah.
And then just rehabilitate Basin 1 and let it do a lot of the job of protecting everything downstream. I think there's a fairly strong argument to be made for that, as opposed to the cost of, well, let's completely retrofit the entire upstream catchment to protect a pretty short length of ephemeral pseudo-natural waterway. That doesn't make a lot of sense to me.
Yeah, exactly.
Yeah.
And like if you say, well, we don't assume any ongoing erosion, and you just reset it for a lot of money, and then it still clogs up again, that wouldn't be a great outcome either.
No, I mean, one question that's worth asking is how much, regardless of whether we think that bit of waterway, this gets into the politics of where budgets come from. But anyway, regardless, and like, where certain funds can be spent and on what, but regardless of whether we think the waterway's eroding or not, what would it cost to do a project to be confident that it wouldn't erode?
Yeah.
Because it might well be the case that the project that leaves us really confident that it's not going to erode any further still only costs a fraction of the cost to reset the basin.
Yeah.
So if you are able to spend basin costs on that project, then even if you thought maybe you didn't need it, it might still be a worthwhile investment.
Yeah, and if you could raise some data, like that might be worth it for the water authority. I don't know. They might have some monitoring programs or something of their assets or something.
Yeah.
I know Melbourne Water, they're starting to monitor their wetlands, the outflows and inflows or not really inflows, but the outflows and the water, the detention times and stuff to actually get some data on their design guidelines. If you design a detention time basin, if it actually has that detention time, previously you calculate it a little bit on the outflow buildings, but of the actual pits and stuff, but you had no real level of confidence besides what music is built on, that it actually has the detention time that you put on the label. And so maybe there's similar initiatives in Queensland that you can go, well, this is a research project for a university or something. We'll try and find out, turbidity of inflows in certain types of catchments.
Yeah. It's interesting that, getting sidetracked now, but interesting that you mentioned about Melbourne Water, looking into the detention time in basins. Because a few years ago I considered, but didn't get around to doing it, buying a whole bunch of water depth loggers, like automated loggers, to stick in constructed wetlands, because there was this discussion happening in Southeast Queensland about, well, we say that the extended detention depth in a wetland is this, that the notional water level is such, and the extended detention is this. But what actually happens? But when you get summer storms back to back, and how long do wetlands actually stay at certain water levels for?
Yeah.
Because certainly the modelling, like spells analysis, would suggest that if you've got quite a seasonal climate where you can get big rainfall events either day after day or a couple of days apart on end for weeks at a time, that you could have a wetland that's meant to have 500 mils of standing water in it, sit with a metre of standing water for 2 weeks, 3 weeks at a time, which is enough to drown a lot of the plants. So, yeah. Okay. Well, look.
So I think it might be worth finding out if there's any, because that's kind of the main decision sort of pinch point, is if there's still ongoing erosion or not. Because then you might, needlessly spend hundreds and thousands of dollars if you don't get that right. So it might be worth having an actual sort of experimental setup to try and find out if that's still the case.
Yeah, I think that's a really good point. I'm going to mull that over some more, but this feels like we're kind of coming to a natural conclusion of this. So why don't we wrap this up here? But couple of things before we go would be, if anyone's been listening to this and has some thoughts they'd like to contribute along any aspect of this project, but particularly along the lines of, is the waterway eroding? What the heck's going on with it? How can we cost effectively figure out more? By all means, get in touch with me. Either comment below on wherever you're watching this video, or you can find me at jack.mullally@ideanthro.com. You can email me that way as well. Let's see what we can find out about this. You never know. If you contact me, you might get roped into a video very shortly as well. So, okay. Well, Herman, thank you for taking time to have a chat. I really appreciate it. And
No worries,
yeah, hopefully we can talk some more soon, because I really enjoyed this. So have a good one.
Of course. Thank you.
Before you go, our best episodes come from your questions. This knowledge base, these discussions that are Ideanthro improve with your contribution. So if there's a topic, an idea, a concept that you would like us to explore, come and ask us. You know where to find us. www.ideanthro.com/contact. You can find us on Facebook, YouTube, LinkedIn, and that place you get your good podcasts from. You know where to find us. We look forward to hearing from you. We'll see you soon.